You like us so much. You are back, and we're also back with a bang. How do you know we back? You because you hit the subscribe and it told you we here. We brought you something else, the differential or difference amplifier. All right, now hit the like as well if you like what you're doing. Get us to feel good about what we do. We're trying to assist with the examinations. We're trying to assist with your knowledge in general. So please do like if it is likable, and then obviously if you hit that subscribe button, it will tell you when we back. We always coming back. We always coming back. Now let's hit you. What have we done so far? I understand that by now you know the what the we started off with what called I don't know why I'm making that big. No, I don't like it. We started off. Let's start with the our famous triangle, and then we have the. We said this is a what? If this is V in and this is V1 and this is V2, rather V1 and V2, um, V1 and V2, we said if this is V out, remember without having to do it all the time, there is VCC and minus VCC always connected in the event that you want either polarity. If you want only the one, give it that one and ground the other one. If you want positive polarity, then supply the positive supply and ground the negative. You want only the negative, ground the positive and supply the negative VCC. But even we do not show this in our sketches, it is assumed that we understand that is there because of the nature of our structures. It will always get in the way as we draw. So now, do you know that this here is going to basically be a comparator? It will compare just two voltages and it will give you and what? So let's suppose you say to yourself, we could improve this though. Yeah, I need to mention that we could improve this. How? We could decide that, you know what, we want to have a scenario where we say, there is my V2. There is my V2, but I want to be able to vary. Oh, no, I put it too high, haven't I? We could say we want to be able to vary the reference voltage. We call this, yeah, I've got the pen, so we call this the reference. If I want, then I can have a port here. Okay, with this port here I can vary, so I can have this voltage here monitoring the other one, and then we could say maybe you shouldn't go beyond a certain value or should go higher. This is us improving on the what, on the comparator, to say we could decide basically that one value is set to a certain level and the other one checks whether it's bigger or smaller. If V1, look, if V1 is higher than than the setting of V2, the reference voltage here, this will be Vref. If this one is higher, look, we'll have a scenario where we have two voltages. Maybe our set voltage can be, our V in can be sinusoidal. Let's have a scenario where I do that. Let me just, I said to myself, I got a question. I said, let me, before I talk of the difference amplifier, which is more or less a similar arrangement except with feedback, we'll do this. We'll say, let's rather have that line there and say, okay, I can decide that I want to watch out for a specific value. So I can say, not sure if that's vertical enough, I think so. So let's say I want to, does it allow me to clean this in between? No, I don't want that. I want to clean this in between. It won't allow me to clean. This is where I don't like this. This is where I really don't like this this software. All right, so it means I'm forced to have to probably take another color. Let me take a different color pen then. I don't want to have to be forced to do this. Let me come here and say I want a line. when it's thinnest, I know it is okay. When it's thinnest, I know it is straight. No. Okay, now I could say line color, say I want white, and come here and say I'll put it there just to separate this. Do I have to do this just to say I want two graph steps? Now what I want there is I want a scenario where I have a reference voltage. My input voltages are here. I'm gonna I've got white. I'm gonna come and say my input voltages are here, V in, and my V out is there. So I will need an x-axis there. Let me go and grab a line and come and say when it's thinnest, I know it is okay, then I know it is vertical. Now we've done this. It's just a reminder. It's just a reminder. Now I want to have another one for this one. This is basically a reminder. What I want to say here is if I've got a reference voltage, let me take that other line, let me drag it to okay, let's come and say I want a line. So I remember this was yeah. Let's say this is where I set my reference voltage to, right? So I set my reference voltage to that value and I say this is my Vref. Then now I come, I just do a simple scenario where I come and I say I've got an input signal, maybe it starts off here and it goes something like that. Okay, general scenario, but every time that it goes above I need to know, every time it's below I might want to know. It depends. This is what I'll then do. I'll come and say okay, if you remember we had, did I remove this cloning? Okay, so I'll come and say let me rather get another line and it calls it a dotted line even though it is not dotted. What I'll do is I hope that's vertical enough. Not really. It looks vertical. Okay, so I'll come and say all right, I want to know each time okay, I don't know if that's perfect. So all I want to do is mark each time that they cross. Why am I doing this? I'm reminding people of our previous work. It's relevant what I will do next. Now what I will do is I will then say these are just markers, it's not real lines. I don't know why it says dot and it's not really a dot, but I wanted it to be a dot. This is not a dot. Dots are like really dots. What are these? These are not dots. These are dashes or something, not dots. But anyway, it is what it is with the software we're using, so we don't seem to have much of a choice. I'll clone this and mark every time that we've done this before. This must be deja vu because we've done this before. So all I'm marking here is every time that the two lines cross. The two. So this is my V in, by the way. I did not mention that this is my V in. And that is my Vref. So I'm comparing, this is a comparator. I'm comparing the practical application. I was asked for a practical application. Said I'll do this before I do the next one. It's one thing. I will then say I want that and to drag this to mark another. You will see that I was playing here, but it doesn't really matter because all it does is compare, because practical situations can vary, the outputs can vary, but as long as they don't cross the threshold, the Vref threshold, then it is still irrelevant to this scenario that we're describing here. Okay, and lastly, fortunately, this is our last line. So what happens here is we need to indicate what happens. Remember, with this guy, if I give it, I want to explain this. If I give it, let's rather have another line. With this guy, if we give him, if we give this guy a reference, that reference will be, if we give this guy anything, an output, I mean to say, if we give it, let me come here, I want to make this dotted as well. Okay, so let me clone this and let me first make it dotted, which is effect dotted, but anyway, we have no choice. We have to come and say we want another one. Remember the output of the comparator. This will either be, remember in actual sense there is there, assuming there's a plus VCC and a minus VCC, assuming there's a plus VCC and a minus VCC, what will then happen is that you will then find that your output, every time that V in is smaller, it means with a higher positive, our output will be positive. So our output will be positive. I did that before, and because of the way it was taking forever, I rather said, let me increase the size of my line. And even though our graphs are supposed to be thin, but just what I'm saying here, I will simply come and say, because V in is smaller, VR is bigger. This is the ref, that small section there. It means that our VR is positive and therefore it's higher. So what happens is that we have a positive output. Oh, I'm trying to write. Okay, our output will be high. That's supposed to be a straight line. That's supposed to be thin, but to highlight what I'm saying, I need to be quick. So at this point here, because that one is higher, it's positive, it's above 0, but it's positive, so it's going to be inverted to a negative. So it will quickly switch. I'm trying to make it straight as quick as I can because I've got other work to get to. This is supposed to be a straight line, and it will switch to indicating that this one is bigger. Okay, now that one there is bigger, so it switches back because we have the first scenario, and it switches, our output goes higher. Now again it will switch. Why? Because the V in is bigger and therefore is inverted to a negative. Now Vref is higher, it's going to switch back. And what do you notice? We have 3 outputs here. When they're equal, output is 0. Okay, when each time they're equal, output is 0. That crossover means actually output is 0. All right, so then, but it will either give us plus VCC or minus VCC, but only if you supplied it with them. If they don't have VCC and minus, then they won't give it to you what they don't have. So how can you be given what is not there? So now you will see that here, that one, the V in was bigger and it was inverted because on the inverting input it was bigger and positive, it's inverted to a negative, so there it is. And then again you've got your ref being bigger and your ref is positive and uninverted, non-inverted, so therefore this will be the shape of your graph. I regret that it's not straight lines, because if we try to use straight lines, it's going to take us a long time. We don't want to dwell too much on this. We've done this previously. It's a refresher. So let's go and say, this is our practical comparator. This is the practical comparator. Okay, this is the comparator. Yes, it was okay without the resistor. We could have just taken that in there. In that case, you can't be able to vary your level. All right, then whatever V in is, or you can compare it like we did previously. It was a what? It was a triangular waveform with a what? With a sinusoidal waveform, just to highlight what you are saying. I thought this would help. So we thought, let's look at it again. Now, if, however, let's suppose I'm gonna do now with the red pen. Okay, I'm gonna say, let me remove this. I want to show people what would happen if this minus VCC was grounded. If this was ground, then where your graph is supposed to come to, where your graph was supposed to come to ground, your graph is supposed to come to ground, it was not going to go without. If your VCC was, it was only going to give you, if your VCC was grounded, if your minus VCC was grounded, it was only going to be able to give you this positive, because the positive is given, and it would give you only, it won't give you the negative. Why? Because you said your negative is 0, your ground. So when it's supposed to be negative, it will only be 0. Okay, it will not go to a negative. You did not give it to, you did not give to it. All right, so now this will be your output if you didn't have, if your minus VCC was grounded. Okay, if your minus VCC was grounded, then it's what you have. If conversely as well, if you had grounded your, if you had grounded your positive VCC, if this was grounded and you did not have positive VCC, your output could never give you positive VCC. Your output would only give you the negative. So where it's supposed to be positive, it will be 0. This is a very, very handy explanation, and bear this in mind, please. So where you don't have a certain supply, you cannot have your output giving it to you. Okay, this is an active instrument, and it only gives you the power it was given. So if you didn't have plus VCC, then your output would only what? Range from minus VCC to 0. Okay, only if you've given them this both can you have both. I hope that makes sense, and I hope it tackles a few. Reason why I had to incorporate this into the next video, this video that I'm going to do next, is because this one is so short. I felt it's going to take probably 2 minutes or so. I said, let me rather revisit the comparator and clarify something. And then now we can talk of our differential amplifier. What is this differential amplifier? It is basically, oh, I still have red. I don't want red. I want a nice pen, and it should be black. My differential amplifier would be, let's call that R1. As usual, our feedback is given to the inverting one. Okay, this will be our feedback. Now we compare with the, for it to be a differential or difference amplifier, we then compare with another network like that, except this one here is grounded. So this will be our V1 and our V2, and this will be our R2 and our R3, and usually R2 is made to be equal to R1, and R3 is made to be equal to RF. This is how our differential amplifier is. So what then happens is our output V out is simply given by, it's an inverting, so it's V out is equal to minus, our output is through that one there, so our it's given by minus RF over R1. Why? Because this is the line for RF. All right, oh, that was a mistake. So by the difference of V1, V2 minus V1. Why V2? V2 does not invert, so it's the positive one, and V1 is the inverting one. So this will be our output. All right. However, in a specific scenario where if and only if R1 is equal to RF, which means is equal to R2 is equal to R3 and RF, because we said R3 is equal to RF. So if R1 is equal to R2, it implies that they are all equal. If this is the case, then our V out, then our V out is simply equal to, because this is going to be 1 over 1, it will simply be V2 minus V1. Minus V1. Okay, so this is it. So this is so short that I didn't want to do the differential amplifier alone. So that's why let me say, you know what, let me go and rather delve and back into whatever and see why I can assist to make this a little bit more, because this was going to be 2 minutes. If we look at how much time we took on this, it's actually literally 2 minutes. So basically we are done. No, not done. We are done with the difference amplifier or the differential amplifier. As you can see, the output. Then what I say here, see, it's good to not immediately shut things down, because now we did not. Oh, okay. Let's rather work with you then and move you backwards. We forgot to say V out. Okay, it's simply the difference of the two. All right. So hopefully this was nice, and hopefully the throwback was a little bit of a helpful hint, or probably useful somehow. I hope you liked it. If you liked it, like us now, and then obviously we'll be back to give you more with a lot of oomph, because you've been encouraging to us. And also hit the subscribe button and notification as well, so you will know, you'll be the first to know when you drop in another delightful session of education. Thank you so much. Till we meet again. Ciao.